close enough, using my awesome new presentation system called 40 by 10, which is just monospace type. So I'm going to talk about this application that we've been working on for a while. There's stats on the next slides. About 5 people, about 4 months in. We have 65 components, 200 tests, 20 dependencies. It's a relatively large project. We're more or less replacing these large desktop applications that have around tens of thousands of users with it. And it's all built in React. Here's our stack. So, of course, React, we're using Flux, the Facebook Flux module, not anything fancy. React Router, Mutable.js, and it's written in the next version of JavaScript, ES6. So I'll just start with kind of showing you what it is. Me first. Space? Awesome. So this is the tool. In the past, we've been launching these kind of map editing tools that were all CSS based. And so if you were to look at, for instance, TileMill, on the right-hand side, there's the code editor. On the left-hand side, there's all the project nonsense. And the beautiful thing about this design is that it just throws tons and tons of complexity into the right-hand side, but it also throws tons and tons of complexity into your mind and how much you have to learn and all of your previous experience and the fact that we expect you to know CSS. And so we're finally admitting that the world is not filled with developers, or that learning new programming languages is a useful use of people's time. And we're building kind of a UI around this. And building a UI around it is pretty tricky because maps are complex things, especially the new kind that we're working on, which are rendered with WebGL, and they use vector tiles, and so they can do a lot of pretty crazy things. So for instance, like on this guy, you can see all the crazy stuff that defines where our text is, and you can rotate the labels of the map if you want to, transform them. You can do a lot of kind of zany stuff. So for instance, make red. And the same for a little bit crazier. These are, of course, styles that real map designers made. I just claim it's my own. So you can kind of do things that are a little bit more beautiful, so to speak, as well as raster data. And so on. And so to build this, there are a few things that are really tricky about it. First of all is that there's a lot of complexity in this data model, and you need to have this matching of the data model of all these layers and all the styles and all the data that's being fed into them with the map and vice versa. And so we have to do relatively complex things like when you toggle a source, it needs to show you in X-ray mode what the source is, and you can click on parts of the source, and it will highlight them and show you what these are. And so these kind of multiple representations of things like this land use, not only here, but in a specific layer, and the two-way data kind of mapping between the two is tricky. Also, just building web applications in general, we tend to write more bugs than we want to. And so a little bit of background about what we've done in the past and why we've switched. So Mapbox is a JavaScript shop. We use Node.js for our main web product, all of our APIs. all of our products so far, except for the few parts that it binds into C++ or has like a pipeline in Python. But in the past, all of our fancy products like TileMill and Mapbox Studio have been built in Backbone with jQuery and underscore templates. I haven't done any of this for like 2 years or 3 years, and between the time that I spent building TileMill 1 and now, my hatred of templates has intensified 100-fold, and I hope that yours has too. The templates were like one of the worst things ever to happen to web development. And so in the meantime, I switched to the strategy of using D3 for everything, because React hadn't been written yet, and D3 had data binding. It wasn't two-way, it was one-way, but it still kind of worked, and you were building your pages the same way that they were modified. And also, interestingly, we had already taken the immutable leap. Who's familiar with immutable JS or immutable data structures? So immutable data structures, I'll go into this in a little bit more detail, but a lot of times they're heralded as a great thing because they make coding functionally pure or bug-free or anything like that. And that's kind of like computer science bullshit, because no programming technique makes software bug-free ever. The one thing that immutable data structures do extremely well is make testing extremely straightforward, and they make undo possible. And that's something that we needed both in previous apps and in this one. There's no approach to undo that works other than using immutable data structures. This was also the first time that we had taken like the transfiled, cross-compiled thing. You can read that as JSX. Kind of the best and worst thing about React. And I think it's right to have mixed feelings about JSX, but it does make the relationship that you have with designers and also with the page a little bit better. It's a useful in-between step. So as far as React, the main thing that I personally like about it is that you can tell that Facebook is using it. There's a problem with a lot of gigantic open source projects that you don't know whether the company is using it and what they're using it for. And so the matchup between your own intentions and theirs is totally unclear. React is pretty good. We've only found 1, possibly 2 bugs in it, minor bugs even. And it's fast enough that we don't have to think about optimizing it most of the time. Library size is a bit of a concern. Here's a really absurd, this is Diskify. It's an open source project that does exactly this. It shows you the breakdown of what's in your project. And so this is our project, and this is React. React is bigger than our project. This is Browserify, the AWS SDK, which is pretty annoying, immutable. But anyway, like React is 560K, which is a little bit excessive and could definitely be slimmed down a bit. Much like the whole idea of like your intentions matching up with what a company is doing. Some of the design decisions in React are only explained by Facebook's weird internal politics. So beware. I'll get to one of those in particular later on. Obligatory React question, just because I saw this discussed last time, state versus props. Of course, state is what your components can control internally, props is what they get, so that's exactly how we treat them. Props are what we use to control things from elsewhere, and state are what we have for temporary self-control. Immutable. The only way to undo, redo. So the most interesting part of our application, which I'll actually just bring up, is this. It's the inside of the Flux data store, and it has these wonderful functions where you can express changes to the style sheet in ways that you can easily undo and redo. And it's kind of amazing. This is the one like totally kill singular feature of immutable.js, is that you can just take a data structure, do a thing to it, and create a new version of it without messing with the past. This is also, as I found from working on a project with new JavaScript developers, the way that people expect things to work already. So matching that is so good. People who are new to JavaScript think that if you assign a variable to another name, that's a copy. That burns. Templates have always sucked. Just want to drive that one home. So who's been using the next version of JavaScript, so-called ECMAScript 6? I would mildly recommend it. I mean, it's bleeding edge stuff, and it feels like bleeding edge stuff in the way that it'll make your life simpler in very narrow ways, but then make your interaction with the outside world a little bit gnarlier. Just like JSX, our browsers have the wonderful ability that when you're looking at a page that's written in ES6, for instance, let's say that I'm looking at this page, I can open up a random file and look at it. And despite this not being the real truth, it'll still show me kind of like what this would look like if it was in ES5. You know, that actually isn't real. It's just a source map telling you that something is real. But on the other hand, you know, weird stuff like GSHint doesn't support it very well. And when it breaks extremely hard. So I only mildly recommend using ES6. It also supports a lot of things that can't just be expressed in ES5, and I would avoid those things like hell. Especially async syntax. Async is like, it's this problem that the more that you think about it, the worse you're doing. Just avoid it. So it's a big project. Let's see. If I look for create class, we have about 65 classes. And lots. We have lots of components. Lots of components doing different things. Lots of room for bugs. React has this wonderful thing called prop types. Does everyone use prop types or know about them? Okay, so a React component is basically like this kind of self-contained. Here's, for instance, the component that shows our map controls. This is what adds the plus and minus buttons to the map, and it controls, it shows where the map is, whatever. Ignore from here on. But it takes these arguments. It takes like whether the map is full screen and a function of making the map full screen. React has this wonderful feature called prop types, which lets you tell it that this component expects a certain kind of props. You can make them required. You can say what type they are. It's more or less a magical way to say in JavaScript that, oh, I want this to be like somewhat strictly typed. And keeping these throughout our application means that when you accidentally refactor out your application and you're calling a component with the totally wrong properties, it will yell at you. You can actually set it to break, which is the best. Number one rule of programming is that you should always prefer hard failure to soft failure. And this allows you to fail harder when you make mistakes. Pause on conf exceptions is my favorite new thing about JavaScript. Does everyone use this? It's like a developer tools thing. It makes your developer tools also yell at you more. And so this is just this magical button down here, and it looks like a stop sign, and it says pause on exceptions when you click it. And what this does is that it prevents JavaScript from failing silently ever. And so, for instance, promises will fail silently. Stuff that is caught by like way overly broad try-catch handlers And this is just terrible because, like, at best, it looks like your application is working and the bug survives until you deploy it, and then you're extra screwed. Or at worst, the bug kind of, bubbles up the chain until it's caught by something else, and it looks like the problem is different than what it is. So I'd recommend that stop sign more than anything else. We also use Sentry on all of our projects, which basically just catches JavaScript errors, sends them to a website, and emails me. JSHint, obviously. Has anyone tried Flow? So it's this new Facebook project, which allows you to write like semi-strictly typed JavaScript. I'm kind of iffy on this because I've implemented it and it didn't catch any bugs, which means that we're either really good programmers or it isn't strict enough. And I think it isn't strict enough. Tests. We use Tape for this project. Tape is a really cool project, which you all should know about if you write JavaScript, whether Node or Browserify or whatever. Tape is like the distillation of tests into the simplest possible thing that basically just says whether things are equal or whether they're okay. It doesn't have any fancy CSS or JavaScript reporters or whatever, but it works extremely well and extremely reliably. And in our case, I don't really, Jest is great, but I don't really understand the appeal in some ways because, like, if you're writing a project that's in browsers, most of the bugs that you find are in browsers. If that wasn't a problem, then web development would be easy. And so Jest using JS DOM and like emulating a browser doesn't make a ton of sense to me. And also we use WebGL in this project, so it would never be able to work. So Flux. We use Flux for this project for our data model, which is pretty great, except for the fact that it requires a lot of typing, but other rule of computer science, typing is not the problem. So like kind of the bloat that Flux makes isn't really important after you type it out the first time, and it just works extremely well. The Flux module is extremely minimal and it doesn't do much, which is really nice. There are other modules that try to do a little bit more, and I've used them for some smaller projects, and they mostly save typing. On to the horrible pain points. Async. So there are like probably 5 or 6 different blog posts of how to do async with React, and they propose about 5 or 6 different ways to do async with React. And like some of them just propose really insane stuff that you would not imagine would be good. Some of them propose really interesting stuff. The one with Facebook says that they have like kind of a message passing bus that everything's passed into and magically returns promises where it needs to and real values where it doesn't, and everything kind of fits together. But it was described in like 2 or 3 sentences, and none of the code is released, so it's not really clear. So refactoring our async implementation is one thing that's just sucked weeks of times, and it totally sucks. Mostly because it's an app-wide concern. You don't want all of your components to be thinking about the fact that they're dealing with async data. If you have a nested structure of like a list of layers plus the layer visibility toggle, you can't say all of those things should be able to accept no data. And you'll always want to lock it. Like, you'll never have a chance to say that, oh, our test should actually create and dispose of users and, style sheets and do this all without a browser. It's just a little bit insane. So our eventual solution has been to use React routers pattern for async, which is actually quite nice. It allows us to have this one centralized function that does all of our async work in the application. So for every time that it renders a page, it asks whether any of the components that it's rendering need async data. It fetches it and delays the transition until that async data is fetched, which is kind of neat on the levels of, first of all, no components need to actually fetch it themselves or think about the fact that they're async. And second of all, this is exactly how a old application would work. So if we ever wanted to, for instance, like render all of these pages on the server side and just dump the data onto the page, it wouldn't be really different at all, because all the routes would just do this on the server side and dump it as one big JSON object and transition immediately. There are drawbacks to this approach. It means that we're even more wedded to React Router, but that's fine with me because React Router is an A+ project. Promises fail silently, which is just, I don't understand why they would, but they do. And also, draining sense of ambiguity and doubt. You know, we came up with this on our own. We're not really sure whether it's the way to do it. And, you know, maybe someday somebody will just walk into the office and be like, no, that's not the right way to do it. Another pain point, transitions. Transitions on the web are the worst thing in the world. So like there's CSS transitions, and there's React transitions, and there are like the third-party transitions that you can use, or D3. This has caused a lot of bugs in our system, and it's regrettable. And you can't really blame the React people. They're doing an extremely good job. The browser implementations of transitions are just like totally insane. React relies on your browser to fire a transition start and a transition end event, and it just doesn't. ES6, I kind of already went over this. It's totally leading edge and whatever. And also, like, ES6 plus these flow annotations is kind of a big question mark of, like, what to do. Because flow annotations are not JavaScript whatsoever, and they're also not JSX, and they're not TypeScript. So, like, you know, we're drinking a lot of the Facebook Kool-Aid here, and I don't know how much more is appropriate to drink. You know, despite Flow being quite awesome. Let's see. That's all I have as far as slides, but I would love to go into more detail if people have technical questions about our love or hate for specific parts of this. Yeah.
I'm interested on the last slide, you talked about using 65 rather than for your transpiler rather than preserve. I'm just wondering why.
Yeah. Oh, the 6-to-5 people rock. I don't know why. Like, it's one of those open source projects where everyone is trying really hard and they're really smart, and like the reasoning is kind of hard to find out. But 6-to-5, it supports more of ES6 than Tracer, and the output that it creates is readable, which is really cool. So even if your source maps fail, you still have like you have the function names, you have the variable names that are roughly the same as what came in.
Do you consider TypeScript at all? Since your plan is also to compile to ES6 in the future?
Yeah,
I'm not a fan, but I'm just wondering.
Yeah, as I said, like we haven't been able to find any bugs with flow annotations, which like you should be able to find bugs, right? Like it's kind of shooting the fish in a barrel. So I'm not sure if we like really wanted to prioritize that first. And also the whole idea that browsers will soon someday implement ES6 is pretty tempting, even if it is just a pipe dream. Like, you know, maybe by the time that we launch this or early next year, Chrome supports ES6 and we just don't have to transpile for a bunch of browsers. It'll be awesome. yeah, I guess there's quite a bit more in this than I went into in detail, especially the fact that we're using, Flux all the way. One thing that I would say is really annoying about Flux is this. The way that Flux creates these constants, I wondered about this for like weeks, why it was doing it this way, because it seems totally absurd. Why wouldn't you just have a list of strings, especially when it's coming out to be a list of strings? The reason is that Facebook uses Clojure compiler internally, and it works with Clojure compiler. And like nobody else uses Clojure compiler, so it's kind of annoying. And also there are easy ways to introduce units into a Flux ecosystem, which are a little bit annoying. Specifically, if you have an action and you just dispatch some action that isn't recognized. Like if I were to forget the W here, like it would just silently fail forever, which is just not cool. I'm kind of bummed that they weren't able to fix that problem. I think when ES6 is actually supported in browsers, you will be able to detect that problem, because the constants will be a proxy, but for now, no. Yep.
You were saying that there are some features in React that are like pretty clearly related to the politics in Facebook?
Yeah.
Like, what are some of those you've noticed?
So
Everything has a like button.
yeah, everything is like button. No, I mean, there's just, I think that's mostly for Flux. Mostly that it's clear that Flux was like, the other things that make Flux make sense aren't released yet. And so it's kind of a confusing thing to use in the middle term.
Right.
And also, like, the whole pattern of using React for a server-side application isn't completely fleshed out. That was one thing that we totally considered at first, but like React expects you to load your data via X, and that X is like the thing that your entire application pivots on. And until they tell you what X is, like everyone's guessing. And so I think like the potential of React being a server, like a server component, is totally unexploited at this point, just because nobody's figured it out. Yep.
Do you use Flux's implementation of, or do you use a Flux-ish store concept in your application?
Yeah. So we have, so for each like main part of our application, we have, style sheet store, map state store, user store. Anything that's data has to go through a store and go through actions. And we use basically exactly the pattern that they use for dispatching actions and all of that nonsense. And I mean, it works quite well. I built a very scaled down application called CoffeeDex recently. And this uses Reflux instead of Flux. It's just an application that this just tells you how much coffee costs anywhere. But the amount of code that I was able to save here was not significant relative to Flux, especially when like the way that the mapping between actions and your store actually is important. Reflux kind of makes this assumption that, oh, you're just going to have like a store that has a JavaScript object and you're going to be adding things to a to-do list, which is wildly different than what we're doing in real life. So some of these just do things in the store, some of them return promises and interact with the web service. Like actions are where you try to contain complexity, I think. These unfortunately do use promises, which is a little bit.
I guess one follow-up, how did you feel like you were able to call out which stores needed to be made relatively effectively, or did you have to stumble and like make some stores that you like, this one can get
we totally messed up for a long time. Like the number of stores has varied from 1 to 7, and we ended up with 4, which like actually being able to get stores correctly is super hard. Especially the relationship between them and whether stores do async, which initially I was like, oh yeah, we're gonna do tons of async in stores. It was just a terrible idea. The main thing that like was useful to me in like as far as this refactoring was that you have to keep stores only thinking about like JavaScript objects and the exact data structure that they're going to mess with, not anything else in the real world or any of your components. You have to keep the list of stuff that stores include at the top as minimal as possible.
At the beginning of your slides, was like avoiding part. I saw should component update. We should avoid that. Why should we avoid should component update?
Has everyone used React Perf? So it's really cool. React Perf is just this thing where you can write perf start and then like, use your application a little bit, then perf.stop, and perf.print wasted. And this will tell you how much useless work your application did. What we found was that, first of all, our application wasn't actually doing much useless work. Like React is very fast at doing the diff between components. And second of all, making some function in JavaScript that actually does reliably say like whether things have changed is quite hard. And so the few times that we were like writing, should component updates, and we were trying to compare like the parts of the state that mattered, those parts would change quickly, and then we would have a bug that was hard to detect. And so like should component update quickly fell into the premature optimization bucket for us.
I'm at Webs. We're still very, very early with needing to look at performance analysis anyway, but like we have done a couple of places. We're using all of our stores are all immutable based, and almost everything flows through props. We try to represent like as much state as we possibly can in the data store, so they are therefore props. But like the should component update we get like basically for free. We've only had to like strap it onto like 2 things, but like we know should component update is whether our props are the same or whether our props are not the same as they just were. So like that's it's a super easy check. Your component automatic like you should get that for every component with basically no cost. It's one of the like if you really have a fully immutable data store, that's really like that preferential integrity is extremely useful for this specific problem.
Yeah, in my case, like using the React component with pure render mixin, and like just doing like shallow comparison, like I've been able to make my application go from like 4-second updates to like 30 milliseconds.
Wow.
Like it's crazy.
Yeah.
And well, it's only possible because I always invalidate object references. So the pure render mixin like only does shallow checks. It's like it's the most, sorry to say the term, but it's like the most ghetto shallow check ever. Like it's just like, okay, is a parent equal? No. Okay, are the immediate children equal? No. Then okay, everything's fine.
Yeah.
So it's not smart, but if you're careful to invalidate object references, I found it to be like insanely good.
Yeah.
Especially with like SVG elements. I tried drawing like a couple hundred SVG rectangles, and it's like if you don't do render skipping, it's like slower than Angular. Ouch! But it's really good. It's just a matter of like really being careful how you use it. Because like if you just throw it everywhere, it's just like totally wasted cycles.
Yeah.
I have two quick questions. One is, I think you said a part about like not liking the like ES7 async await syntax.
Yeah.
Can you just like talk about why?
Well, because
You also said you didn't like promises.
yeah. I mean, I think promises are fine except for the fact that they eat all errors by default, which is really problematic in our application. And like promises are expressible with callbacks, so like I think that we're kind of bike shedding on async in JavaScript. So the await syntax just gets me because even if you use something like 6 to 5, what it compiles down to doesn't look like JavaScript, and that scares me quite a bit. So like if there is something, when generators actually land in browsers, like that might be an interesting thing to explore. But until then, like it's a bit too much of an illusion.
And then the second question is, we use Sentry too, and we've noticed with React, this might be because we're doing server rendering, but in production mode, like half of our errors are just like minified error.
Trace that suck. Yeah.
Okay. And
Yeah.
are you doing? Do you have any tips?
No, I mean, no. Mostly what I do at this stage is teach everyone in my office how to debug JavaScript, but that's not really scalable.
And like a lot of it, it's like some weird browser thing you can't really recreate. So
Yeah, that's pretty rough. Yeah, I mean, so as far as performance, the one thing that we actually have run into that is a performance problem is using gigantic loops and immutable, and using React router wrong. Like if you transition routes 10 times a second, your application is not going to work very well. Because React router does like an insane amount of magic to the point that I was really skeptical of it first, but it pulls off the magic pretty well. Yeah.
On that, can you talk about is there interplay and what's it look like between the dispatcher and the React router?
Between dispatcher, no. So
Because you talked to, I guess, some of what you use React router for and where that fits into your application.
yeah, sure. So React router is really unusual for me because it's not just a router; it's actually like a way to set out your pages. And so this page layout at the top of here, I go to it in my React tab, like this part is a route, this part is a route, and this part is a route. Like the page is actually set up so that this whole block of content refers to edit. The fact that this is on and then that this exists refers to layers, and then the name of the layer background triggers this to exist. And in code, it actually looks very similar to that. So if I look at, for instance, my layers, you'll see that I have like this CSS transition, which I hate, but of the route handler, and this route handler is actually like the layer. And right above this is all the other kind of junk that we have for the layer list and whatever. But React router is what gives us this connection between like this component contains this other route, and we just have this really nice stacking. I think another place you can see this is in our routes. So you just have one place where you define the entire structure of your application. And so at the top of this structure, we have style menu, which is this. The next thing is workspace, which is this. And then let's say that you have the constants route. This is the constants route, and then this is the constant route. And so React Router does a really amazing job of linking all of these things together in a pretty logical way, because you're like building your page layout in a way that reflects your URLs, in a way that reflects your data. The bizarre thing about this is that it also adds this global state to your application. So something like this constant route this guy can get a mix-in called navigation, one called state. These are both from React Router. And this can just ask what the URL parameters are. And this gives me super weird feelings. I don't know whether it's a good thing or a bad thing, but it definitely is convenient. And React Router also just does the magic work of saying that whenever your URL changes, it is going to re-render your application for you, whether you like it or not. And so when you press the back button, it gets rid of that route, and it eliminates that component, transitions it in and out. Pretty crazy. The other thing that React Router does for you is, at least in our case, before rendering each route, it does all of our async work. It states like
Using the wizard.
yeah. Also, these guys are crazy. So like React moves at a fast pace, and React Router moves at like an insane pace, where the developers who run it will just be like, well, we changed all the APIs, and it's released tomorrow, and then on Friday we're changing them all again. But they make almost all good decisions, so I'm pretty cool with that. Yep.
So you're using Simplify to do all your compiling?
Yep.
So in your, how 65 doesn't know anything about JSX, right?
It does.
It does.
Yeah, 65 does JSX itself.
So you don't have to like somehow marry the React tool JSX with.
Nope. Our only browserify transform is 65. 65 and 5. And those folks, like, I really am just trying to figure out why they're doing it. Because they're working on it day and night. It's insane. It's just like this guy out of Kiev and this guy out of London. But 65 has its own parser, which is quite good, based on Acorn. It does JSX, and it will do flow annotations in itself. It's slightly slower than Tracer, but since we use Watchify for this project, and Watchify caches updates, so our rebuilds are pretty fast. Without that caching, they're extremely slow, because I mean this application is gigantic. Yeah.
How much have you cared about keying, and when did you start caring about it? How much is it?
Oh, that's another thing that I just don't understand about React, is why it just doesn't throw an exception as soon as it sees something that's keyed. So keying gets us every once in a while. It can introduce really bad bugs that only show up after the application has been running. Why it's there is kind of weird. Yeah, it's been a bit of an annoyance, but I can see why they're doing it.
You key everything.
Yeah, you have to. You gotta key. You gotta key things. The one really bad practice that we did for a little while was that we would always just have like, some object.map and then have a bunch of divs, and we would just key them by intervals, which was terrible, and that introduced all kinds of bugs. Because then if you like update one of them or you resort them, then it doesn't resort them, it just re-renders all of them. And like we have, in your layers list, for instance, you can sort this list, you can select things out of it and delete just those things. Like all of the crazy CRUD operations that you can imagine we've done. So it has to work really well. I don't want to do that. So that's the cool thing about people's data structures. I highly recommend using them. Anything else?
Are you pretty happy with it?
Yeah.
Are you happy with your findings?
Yeah. Yeah, I mean, as far as web projects go, the bug surface has been reduced quite a bit. It works quite well. But, like, the cultural qualms of transitioning code-based projects to UI-based projects are more than just code itself. So that's a whole other nut to crack. If it's easy to use as Photoshop, then we'll have people making DVD lectures of how to use it, which I don't know whether that's positive or negative.